I would now like to hand over to Armin Nababi for our first presentation.
Hello. Hello to everyone. Today I'm going to present a project with the title of an AI-based automated information inquiry framework for BIM. My advisors in this project were Dr. Issa Ramaji and Dr. Naima Sadeghi. For the beginning, I'm going to present the key project information. What's the challenge, what's the solution, what's our method to implement the solution, and after that, I'm going to talk about the openBIM solution we utilized in our methodology. And finally, I will talk about how we evaluated this project and about the outcomes and the contributions. As we all know, various practical information can be obtained from BIM models during the project lifecycle. There are several BIM softwares that we can access to our required information through them. Softwares such as Navisworks, Revit, BIM 360, etc. The challenge is that access to this information mostly could be tedious and time-consuming, even for an expert who wants to search in the model manually. And also, most of the stakeholders of the project who need many information from BIM models during the project lifecycle have limited or no knowledge of working with BIM softwares. One solution that comes to mind is automating the information inquiry process. A vocal question answering system can do that, just like what Google, Apple, and Amazon did with the creation of Google Assistant, Siri, and Alexa. For creating a question answering system precisely, we must focus on 4 different parameters. First, the accuracy of the answer must be in a high rate. 2, the system should significantly understand the user's purpose. It can be done by understanding the syntax variations and semantic complexities of the question. 3, the speed of the answering process must be in a high rate, and at least it should be faster than the manual search. And finally, the system should be easy to use and have a user-friendly environment. After reviewing the literature and recent research, 2 gaps were found. First, most of the information extraction frameworks are keyboard-based with low accuracy. Actually, most of these frameworks cannot semantically understand the purpose of the user and cannot understand the semantic complexities of the question. And 2, there are few research for facilitating access to 4D BIM information. Therefore, in this research, we try to facilitate access to 4D BIM information and at the same time try to understand the semantic complexities of the questions. Now let's go for the methodology. As we all know, there are lots of question types related to 4D BIM that one can ask during the project lifecycle. Therefore, we decided to facilitate access to the most common, frequent, and essential question types related to 4D BIM. In order to achieve it, a questionnaire was designed and distributed between the people who are involved in the project, and they were asked to determine the most common and frequent questions that they want their answers immediately during the project lifecycle. And finally, after analyzing the questionnaire, 6 question types were determined. The first question type is the most common and frequent question type with 5 different 4D related BIM questions in follow. Okay.
Yeah, that's working for us now.
Okay. Here I talked about the challenge, the solution, about creating a vocal question answering system. After that, the research focus. After that, the recent research gaps. And after that, a questionnaire was designed with 6 that it could determine the most 6 common question types. Okay, now let's go for continue.
Perfect, thank you.
Okay. In a question answering system, a user should be able to ask his question through voice. First of all, we should turn this voice into text because the computers can deal with text easier and better than voice. We employed Google Web Speech API to achieve it, to turn the speech into text. Since there are 6 different question types, 6 functions must be designed to answer each one of these question types respectively. Therefore, the system should be able to first determine the question type and then activate the related function to answer the question. For getting this task done, we utilized Support Vector Machine Classification Algorithm, or SVM algorithm. First, we created a dataset containing several sample questions and labeled them from 1 to 6, representing their question type. Then we processed this dataset to be prepared by learning by SVM algorithm. Natural language processing, or NLP techniques, was utilized to prepare the dataset. In the following slides, I will discuss how NLP works. Finally, a classification model was created that takes the user's question as input and determine the question type with a label from 1 to 6. After determining the question type, we must analyze the user's question to determine his purpose. We did it in 2 phases. First, syntactic analysis to determine the keywords of the question utilizing natural language processing, or NLP. In the phase 2, we try to semantically understand the user's question utilizing ontology. In other words, by the combination of NLP and ontology, we try to make the computer understand the user's question just like a human. Now let's see what natural language processing is. NLP is an approach for computers to analyze, understand, and manipulate human natural language text or speech for some tasks. NLP has several techniques, such as tokenization, which splits a text into words, as you see in the first figure. The other useful technique of NLP, do you now see the NLP, natural language processing?
Yes, we can see it now.
Okay. The other useful NLP technique is part of speech tagging, or POS tagging, which determines the role of each word in the text. In this project, the keywords of the question are the noun phrases. Therefore, we utilized a POS tagging technique to specify the noun phrases as the keywords of the question. There are also other techniques such as removing stop words, stemming or lemmatizing, which give you the stem and the standard form of the keyboard that we utilized in this project. Let's go for ontology. Keywords alone cannot indicate the purpose of the question and the purpose of the user. For example, there are different terms with the same meaning. Imagine one word that exists in the BIM model, for example, the word beam. If the user used a synonym of beam instead of beam, for example, used the word girder or arbor in his question, no answer will return to him because the word girder or arbor does not exist in the BIM model. Instead, their synonym beam exists in the model. So it's required to expand the keywords of the question with their synonyms. For such tasks, we used ontology. Ontology consists of concepts or classes, properties, relationships, etc. There are 2 types of ontology. First, a general ontology, which categorizes all of the words in all fields, like WordNet. And 2, a domain ontology, which contains only specific terms that exist in a particular domain, like IFCL. IFCL is a domain ontology that contains construction industry terms. In the following slides, I will discuss how we used NLP, we used ontology in our research. Okay. After collecting the keywords and their expanded concepts, they must be searched in the model to understand the user's need from the model. First, through Navisworks API, we extracted all the list of tasks, materials, objects, and layers of the BIM model from it and save it as a database. Then the target terms, which are keywords and their expanded concepts or synonyms, searched in the database to shape a final query. For example, if the user asks a question, how much volume of concrete is needed for floor in third floor? A final query will be shaped in the way that concrete would be a material, floor would be an object, and third floor would be a layer. As I discussed, from natural language processing and ontology, the keywords and their synonyms were found. And after searching in the model, a final query was shaped. On the other hand, with the help of support vector machine classification algorithm, the question type of the user was determined. Finally, the function related to the query type will be activated and will take the final query as the input and search in the model and calculate for the answer and finally show the answer to the user. Our system is implemented as a plugin for Navisworks application. The user can press the microphone button and ask his question through voice, and the system will interact with the user through voice, and finally it will show him the answer. Also, the system shows the elements or objects that are related to the answer. Here is a 1-minute video of how our system works.
Hello, I'm here to answer your questions. Please click on the microphone button and then ask your question. Please ask your question.
How much cubic meter of concrete is needed for third floor?
Now the system is converting my voice in a text and it will display it in the text bar so I can edit it if I want to. After confirming the text and pressing the continue button, the system will analyze the question, determining the question type, and search for the answer in the model.
Do you want the quantity of material in a location or the whole project?
Yes.
The volume of concrete cast in place graver is 214.52 cubic meter.
Okay, now it's time to discuss the openBIM solution we used in our research. As I mentioned, IFCL is a domain ontology. IFC provides a web ontology language representation of the IFC schema. IFCL is a web of linked data that facilitates data management in the construction industry. The process of keyword expansion, which is adding synonyms to keywords of the user, have done with two phases. In the first phase, in the first stage, imagine that the user asks something about arbor from the model. First, we should replace the keyword of the user, which is arbor, with its synonym that exists in the ontology. For example, when the user asks something about arbor, arbor does not exist in the IFCL, in the ontology. So it should be replaced by something that exists in the ontology. First, we used a general ontology like WordNet to collect general synonyms of the word arbor. The general synonyms, as you see, are ridged, beam, purlin, and bolster. Then we will search these synonyms into the domain ontology, which is IFCL, and see that the word beam exists in the ontology. Therefore, the word arbor will be replaced with the word beam. For the second stage, semantically adjacent concepts of the word beam should be extracted from the ontology according to their semantic similarity. There are several semantic similarity computing studies, and we chose Likhat-Chodorov or LCH semantic similarity formula to calculate the semantic similarity value of every word that exists in the ontology with the word beam in this example. Finally, concepts with low semantic similarity value that are below the threshold that we defined manually will be abandoned, and only the most similar concept will be added to the standard concept beam. For the evaluation of this project, 5 experts in working with Navisworks software and 5 non-experts volunteered to ask several questions in each question type from a sample BIM model. This research was evaluated from 3 points of view. First, about query classification, about how many times could our system correctly determine the question type. As you see in all question types, the accuracy is over 90%. Two, from the perspective of understanding the user's question, the system the accuracy is more than 75%. And 3, the response speed of our project is acceptable compared to Navisworks quantity takeoff. Our system is 2 to 5 times faster than Navisworks quantity takeoff. Our system also has some advantages. First, automating answering of essential question types in the construction phase. 2, the system could facilitate access to 40 BIM information for non-technical users who have limit or no knowledge of working with BIM softwares. And 3, this system creates a more user-friendly environment for Navisworks application. And finally, about the outcomes and contributions, for the BIM essential information was accurately discovered by this research. 2, the system eliminates time-consuming manual search in BIM models. 3, the system significantly reduced the time of question answering process. And finally, our system could understand the exact purpose of the user using NLP and openBIM. Here you see the collaborators of the project, Dr. Issa Ramaji and Dr. Naima Sadeh. And thank you for your hearing my presentation. Thank you for your attention.
Thank you, Amin. I'm going to put you back into the backstage. We'll save all the questions until the end of the presentations. If you can just hang in there, that would be perfect.
Thank you.
So now I'd like to introduce Abdulaziz Juraboev from THM.
Hello, everyone. Hello, good morning, or hello, ladies and gentlemen. So my name is Abdulaziz Juraboev from the University of Applied Sciences Mittelhessen in Germany. Today, I would like to talk about my master thesis that I applied for this award. So about my theme was implementation of RFID and wireless IoT technologies in building information modeling. In the current research that we have is based on the implementing of RFID transponders to integration of RFID tags into structural materials as physical gateways to the digital world. So you see here on the first slide, IFC logo. So IFC, we use IFC model, IFC files, and we use also RFID tags and create then numerous applications. It could be also cross-platform applications. So the idea is through integrating of RFID tags into physical objects and connecting via unique ID of RFID tags to connect the physical world with a digital world. In my master thesis, I created an application named openBIM. So it's a digital tool for information exchange based on the IFC scheme and RFID tags. So we have several application use cases. For example, we can use it by partnership cooperation of various specialist trades for data exchange in order to get better insight into the coordination of production and stock and construction trades via the RFID tags that uniquely identify identification of the construction materials into in life cycle of the construction. So in the second, we have also in production planning, that important here is in the production planning, we embed RFID tags into structural materials in different components in order to link then with the help of RFID unique serial number into physical objects and in the early construction stage as possible. It's useful for supply chain management, and in the third, we can also use a real-time status information tracking. This ensures to no standstill times and less storage space is a requirement, and by the just-in-time delivery of materials and construction progress control. And in operations where we use the buildings and infrastructure objects are mostly mostly used the use cases. There are also several use cases. It helps for the efficient facility management and also for continual updated digital documentation of maintenance and repair work with the help of status information that can be actualized by scanning of the tag. So, and also one use case in my thesis that I wrote more focus is a centimeter accurate pedestrian guidance system for the visually impaired people. So visually impaired people, they have, or blind people, they have stock in the hand, and with this, we integrate RFID tags on the floor coverage, and they scan it and get information from the BIM model. And also, it's useful, as I said, in the entire life cycle of the building and construction materials for the traceability of building materials via UID number, for example. So the key openBIM information is here. So the basis for the implementation of my idea consists of the following three components. So we have openBIM approach and for modeling, and also attributing and tagging the objects, and development of the application platform. So first, we need the integration of innovative technologies like inter-BIM models by the planning phase. Here I use the international standard IFC format to export from the Revit that I use the Autodesk Revit in my software. So, and then secondly, to integrate the tags into physical building materials in order to create a connection between the virtual and digital building models and the physical buildings structure. So, of course, we can here integrate other types of tags like beacons or sensors. For this, further investigations are necessary. So nowadays, sensors are already have integrated or emitted to IC, but RFID tags or RFID that I in my research is not integrated yet in the IC 4. So, and that's thirdly to develop one or more web applications for various use cases, for example, for a blind navigation system or for tracking of production components, concrete components, for example, into a construction site. So how we can achieve the standardization of the methodology here, for example, I will bring here first plan digitally and then to build physically. We need to integrate RFID tags into building materials. There are some methods, for example, by integrating on the surface or during the production phase. So in this, we see here built RFID on basis of IFC tree structure. In this, we have the proxy identification definition, IFC building element proxy that I used because for undefined non-standard structural elements. And here, in this functions, for example, the RFID tag objects or like child elements created in by the planning of BIM model, and exported in IFC format. IFC models were identified with the help of the proxy function, IFC building element proxy, and compiled in a list. So then the identified RFID tag objects were assigned to the associated components, elements, for example. There is parent elements. And then the function describes search the IFC model for all elements of the type, for example, IFC building element proxy, and create an RFID list with the associated property sets and the elements found, such as the identification number and also audio data number, audio data that I link it to them in this application. So next. And then in the second stage, embedding RFID text into structural materials. Here, reasons that I used UHF RFID text with the dimensions, different dimensions are their robustness tags have excellent reading ranges, are better, so they don't need a battery with they functions with radio waves. It's cost effective and last a long time, about 20 and 50 years, depending on the robustness and protective. So on the right side, we see the installation of RFID tags on the modular carpet, for example, or concrete slabs to creating point-based navigation system. Or we can also install the RFID tags into a manhole or any kind of elements and during the production phase. So, and third, openBIM source framework application that prototype OpenNaviBIM is 100% open source software framework, and the approach is a standardized neutral data exchange format for BIM models. I used IFC format and RFID and BIM model-based navigation in order to create RFID and BIM model-based navigation and positioning system. On the right side, we see the used files. I used the IFC.js BIM tool for JavaScript and with the Swiss.js. and backend tools and other for framework are illustrated. So the outcome was in this overview that I was explaining before. For the proof of concept, the selected software applications are freely available, all as an open source, and can be freely installed in any platform such as Microsoft Windows or Mac operating systems. So first, complete digital building model was exported into the open source IFC format. Then the database system, here I use MongoDB, and JavaScript server like Meteor.js was set up as backend, and IFC.js and 3.js were used to load and display and edit the IFC models in a browser or in app on the app. So with the help of IFC.js, the IFC models, including all their information, can be visualized and in common browsers or mobile devices. We can use any kind of open source database here, and through the connecting the RFID reader and to the openBIM app here, the applications on a smartphone using the text works very well now. And by scanning or by reading the text with the help of, for example, RFID reader or peripheral devices like blind white cane, it's possible to link BIM-based information in my application. So now I would like to demonstrate shortly in the video. We are scanning now with a blind white cane the RFID tags that are integrated into the structure materials. By scanning,
you are located in front of the stairwell door. Here is the main entrance and exit.
I can all informations like audio information, or we can create for navigation system by scanning of the RFID tags that are integrated into real structural materials. And also for other use cases are, for example, for hidden objects in the ground, when we integrate tags that we can scan it and in order to get the information. And it's also possible nowadays.
You are located in front of the stairwell door. Here is the main entrance and exit.
Okay. What are the benefits of extending IFC through RFID technology? Are so for the real-time information along the entire life cycle, from planning over production and construction to operation, the real-time component tracking or target actual dates of construction site progress can be compared. It saves time, effort, and money through material tracking for real-time lean construction management, and also for real-time status information exchange along the entire life cycle from the material production to construction completion. Is good for quality assurance of materials, and we have clear allocation and detection of materials. So with the use of, we don't need to convert IFC files into other data formats, for example, by using IFC.js packages. And we can create also a centimeter accurate BIM model based navigation system, where, for example, GPS don't function in indoor navigation system and localization system for the visually and physically impaired people. Why in this case, for example, RFID tags? Because we need a scanner. Without a scanner, it's not possible to read the passive tags. So this was my presentation for today. Thank you very much. My master thesis were also supported by the community of IFCJS. I'm very thankful, and I'm sorry for my English. This is now I'm practicing it. Thank you very much.
Thank you very much, Abdulaziz. We'll save questions for the end, so if you can just wait in the backstage area until the end, we'll bring you back on for questions from the jury.
Okay.
Thank you. And now to hand over to Konstantin Hobart and Christian Schranz. I'll just get your slides up for you.
So, hello everyone. My name is Konstantin Hobart. I'm really honored to be here and presenting our project AR supported teaching, which has involved from my master thesis and then here from the research unit on this of the Center of Digital Building Process from the Department of Civil and Environmental Engineering at TU Vienna. So we are working with on improving the teaching experience for civil engineering students. This is how civil engineering education has looked like traditionally. Two-dimensional plans for problems which are inherently three-dimensional. And so augmented reality is an up-and-coming, new emerging technology which can help to visualize 3D problems. And we thought about and prototyped different solutions to help students to learn about civil engineering in a more approachable way. But when investigating this area of augmented reality software solutions, we found that many solutions are part of a closed-off ecosystem, which inhibits their use in a teaching setting, as it limits the shareability and reusability of teaching content, or they are part of an open source library and are very capable, but also require programming skills. This is why we started building our own platform called AR Supported Teaching, which is a platform where students and teachers come together and explore IFC files. And as our research unit is really focused on the use and promotion of the use of openBIM, we chose this open standard IFC, and it's split up into 3 applications. The first one is the editor, desktop editor application, where you can import 1 or more IFC files and add information in the form of text, video, and images. These are didactic elements. Additionally, animations are possible, which can show the structure of a building in better detail. Annotations can be placed alongside the surface. These are the little flags you can see. And lastly, we have a layering system, which we use to hide and show different parts of the geometry and thereby visualize a step-by-step procedure in a building process. This teaching scene can then be downloaded on the Augmented Reality Viewer platform for Android devices. The teaching scenes are positioned into the real world and can be viewed from all sides. And we integrated a live session to the editor, where teachers and students come together and exchange chat and voice messages, as well as 3D pointers. Lastly, the website is the link between the editor and viewer application, where we allow teachers to create groups of students, assign editor rights, as well as have a project overview and can edit titles and descriptions there. So how is such a teaching scene created? Firstly, you start off with an IFC built in a native 3D authoring software. You import that into our editor and enrich it with explanations and informations. which are stored inside the JSON file. And this IFC and JSON get transferred to the web application where the access management is handled, and then can be downloaded inside the viewer application. And again, we have this live session where teachers and students come together to discuss the project. Over the last year, we published around 40 different teaching scenes covering a wide variety of basic civil engineering problems, from timber construction to concrete buildings. Now, how comes openBIM to play in our project? We really focused on IFC as an import option, which allows us to be independent from a single software manufacturer. All our teaching scenes are stored as IFC, which future-proofs our efforts. And we also think that it's very important for our students to learn to work with openBIM at a very early stage in their studies, as well as get some experience with a new and an emerging technology, augmented reality. And we also think that our project is a use case example of the multi-purpose facet of openBIM. Now, I want to show you the flow of an IFC file through our platform. So you, again, import it into the desktop editor, where it's split up into the geometric and non-geometric information. The geometric information is handled by a Unity 3D plugin called 3D Loader, and the non-geometric information is handled with an open source tool called IFC OpenShell. This produces an XML output, and we merge this XML together with the added informations inside the JSON file. And these two files get transferred to the server, and then after an access control to the viewer. And again, the live session can be started from the editor, and multiple viewers can join and exchange messages via WebSockets. Now, in detail, our key outcomes is the editor application, where IFC data is loaded, and the model can be viewed like in any traditional viewer. And you also can select different building elements, either in the scene or in the hierarchy. Additionally, we allow the hiding of certain more longer IFC properties to allow to reduce the information density for a teaching setting. This editor has now been reworked in the last year to also be built as part of a web platform, like you have seen in the earlier project, again with IFC.js. We allow the additions of buttons and layers, where buttons are created which show up on the viewer later, and layers which can be assigned to these buttons. And then you can select freely different building elements, either inside the hierarchy or inside the scene view. And this allows to visualize step-by-step procedures again. And you can check if the assignments worked out. And lastly, the placement of these annotations can freely along the surface. You can add a title and description, assign them to layers as well, and load insert a video or an image. And this is how this the scene would look like on the editor, on the viewer application. Left, you see the buttons, and on the right, you get the information on the selected element, which is either a building element or the annotation. And you can enlarge the images and videos and look at the model from all sides and access these step-by-step visualizations. Additionally, as I said, we have this animation system, which can be used to create more advanced scenes. Here we show the layering of a building and want to highlight the solar panels, which are integrated into the window fronts. This was an example from the Ministry of Sustainability and Tourism in Austria, and they are building a new teaching center and came to us to work together to build an augmented reality visualization for the project. Then we evaluated our efforts. So this viewer application was evaluated with the handheld augmented reality usability scale, which is a usability scale that aims to uncover common usability problems with augmented reality applications on smartphones and tablets. Here we only scored okay, mostly due to the students being first-time users of augmented reality, and they had issues with the large tablet, so we would probably downsize the tablet in future tests. We scored a bit better with the editor application, where we applied the system usability score. Here there were some inconsistencies inside the user interface, and that's also one reason why we re-implemented the goal editor inside the web platform, which unfortunately is not finished right now. But the key takeaway for us, and also why we are still pursuing this project, is that students felt that the learning effect was really quite good with augmented reality, and it can increase the teaching, the learning efforts. Again, this is part of my master's thesis on AR training application and authoring tool for 3D BIM visualization in civil engineering, which was a joint effort from the Department of Informatics and Department of Civil Engineering. And building upon that, our research unit published a paper on augmented reality in AEC education, a case study, where different solutions were compared and also the previous usability study was done. And then I want to give over to Christian.
So actually, I'm very happy that Konstantin did this AR supported teaching for us, because several years ago, once a guy asked us and said, we have a problem in the practice. When you look at the ceiling of a flat roof, a lot of people make that wrong, and we want to teach our workers how to do that right. And so after years later, we met Konstantin, who was then the programmer. And again, we're working together with the industry. So we have several civil engineering offices. You see some of the biggest one in Austria. And they use this platform not only for teaching their workers, they also use it for the communication to the construction site now. Because when you have a problem on the construction site, sometimes the worker can call and say, we have a problem, we don't know how to do this detail. And then they can use the BIM model and use the part of the BIM model and make an AR teaching scene. So this was a use case which we weren't thinking about when we started with Konstantin, but which arose during the process and also during the feedback. You saw the evaluation. And then we're working together with some institutes in our department. So the one is for concrete engineering. You could see some use cases there. The other one is for water resources, and also together with building physics, where they use these details for teaching the students and even testing the students. So they can build scenes during a test, and the teacher can check if it's right or not. Then we're working together with different departments, with the Department of Informatics, and also with the Department of Geoinformatics. They are using a lot of AR, and now they're learning IFC. And in Austria, we have this special case of technical high schools. So we have high schools which are for civil engineers and which are taught civil engineering. And teachers and students of this high school are also working together. And some of the scenes you could see on this overview, they were created by these high schools. And the nice thing is that they create scenes which they're not using only for themselves, but they're using also for other high schools. So it's not only like a closed, again, we're making closed content just for our school, but we're sharing the content with others and we can discuss over the content. And in the last 2 years, we had also this Corona pandemic, and through the live session, the students can work at home and the teacher can talk and discuss during the same platform. And a pretty new use case which just emerged was together with the city of Vienna. Vienna is working in a big project, as I think many countries are doing actually, on the digital building permit process. And there's one case where the neighbors of this construction site have rights to be against, let's say it this way, to be against some parts of a construction. And so the problem they had in the past is they were looking at plans. And plan is something which is very easy to read for civil engineering and architects, but much more difficult for people who are not from this field. And then we created the saying that the people who hand in the BIM model, this BIM model can be used to make a real size 3D model in augmented reality. And you can watch with the tablet on the construction site how the new building would look like. It reminds me a little bit of Switzerland, where they have the sticks going out so that you get a little bit of imagination. But in this case, you would see the real building just as a virtual model in the real environment. To add, we just got an inquiry 2 weeks ago if we can use it also for other cities in Europe. There's this European network for digital building permits, and I think this is a nice use case which can also help to make the involvement of citizens. Yeah, Constantine, sorry. And so I think we can use openBIM for different things, for open projects, also for open teaching. And this is something where Constantine was working on his master's thesis and is now improving. It's really looking nice, and we are happy also to include openBIM much more to the teaching of our students. So thanks again for listening, for your attention, and for your time. And again, sorry that I can't be in Montreal. As some might know, I just got COVID a week ago.
Thank you.
Thank you very much. We're going to hand over to the jury now. For the jury, when you're asking your questions, I will come around with the microphone just to make sure that everyone can hear the question clearly. Who would like to?
First of all three projects are amazing. Thank you for sharing these. I would like to make the same question to all of you. I believe you find some issue during your research, so I would be interested to understand which one was and how you overcome that.
Yeah, a real issue was working with augmented reality for the first time, because there are many different solutions out there and different approaches, but they are so rapidly evolving. I started writing, and 2 months later there were even new libraries and even new solutions out there. So I basically, I think I restarted around 3 times the implementation for the augmented reality to keep up with this new and improved solutions. But in the end, I think it was really worth it, because there were a lot of improvements done by Google and by Apple to really improve these augmented reality experiences. So that was my major challenge here.
Abdulaziz, so we go to you next.
Yes, the audio is not so good. Can you please repeat one more time?
Thank you.
The question.
I was wondering which issue did you find while doing this research, and how you overcome with that?
By using in the programming phase, it took a lot of times to reload deploy reload the BIM model. When I scan it, the idea was to scan the RFID tag and, in this case, to load the BIM model. It took a lot of time, and then the solution is for creating a blind navigation system, so they don't need to see the BIM model and only to get the information. And this was due to using property sets that in the hierarchy that when we search RFID ID that integrated to BIM model with element ID, and it took a lot of time this is a problem nowadays when we have property sets for extra for like sensors have for to integrating a unique ID for the BIM models, for example. It could be better to easily to search and load the models.
Thank you.
Thank you. And now Armin, the same question to you.
The main problem in my research was the part of understanding the semantic complexities of the question, and I was wondering what should I do in this research. Many research utilized ontologies, and they could not achieve a good accuracy in answering process. But after advising of my advisors, we trusted in IFCL and choose it. And after examining it, we found out that the accuracy can be in a high rate after using it.
Thank you. Are there any other questions from the jury? Oh, who would like to? I'll type it in the chat as well.
I'll go to the camera as well so they can see me. Hi, thank you everybody for the great presentations. I have a question for each of you. I'll just go through them quickly. Armin, since you are already online, can you hear me?
Yes, I can hear you.
Okay. My question to you was, why did you choose Navisworks to show how it works? And would it work also with, let's say, a Revit file, or is it an explicit requirement to have an IFC file for the speech recognition to work?
Okay. Since one of our goals was facilitating access to 4D information during the construction phase, the most utilized application that is used in the construction phase in Iran, it is Navisworks, and therefore we choose this application because it was in every company, and they was familiar with it in the construction phase. Would it be?
And do you need an
no, it is just work with Navisworks file.
Okay, so I could import a Revit file into Navisworks and your application would work as well?
Yes.
Okay, thank you. Abdulaziz?
Yes.
Can you hear me all right?
Yes.
I was wondering if during your research you used the building element proxy to kind of link to the tags, but do you see a need that the IFC schema should be extended to also incorporate tags like this?
And that time that I last year in my as I wrote my thesis to extending the IFC to exporting into 2 and 3 and the view from the when I export the IFC 4.0, for example, it was not possible to use RFID, for example, the IDs. Therefore, I used proxy element.
But do you have a recommendation for developing IFC?
I have. Schema? Yes, I have the recommendation to extend IFC to integrating unique identification number. Nowadays, we know that construction products also are getting in the industry if you heard about, for example, standardization of C1 for identification number, they get identification number. We could integrate the RFID tags, for example, passive tags that live longer, and then extend the IC for RFID tags.
Okay, thank you. And for Konstantin, I don't have to use a mic, luckily. I was just wondering, have you, right now you're using the tablets and the phones to do the augmented reality, but have you also looked at maybe using virtual reality and headsets with AR capability?
So we started off with the tablets and smartphones because they are more widely available, but we also have an open research position or a master thesis for the use of our application together with the Microsoft HoloLens. Again, we focus on the tablets and smartphones because they enable a sort of group activity with students that with headsets you're always limited to only one person during the experience, or you need a lot of HoloLenses and they are expensive and really were quite rare when we started off with the project. So those are some limitations, and for virtual reality, this is something which can be added quite easily into our system, but currently there are other departments inside of the university who specialize in virtual reality. That's why we are not really pursuing this right now. Maybe Christian can add something to this as well.
We didn't use virtual reality right now. We started with with augmented reality, but the extension to virtual reality we would use, and we would talk with the people in the Department of Informatics, which are experts in this field, so that we can also make the usability easier. When you looked at our AR viewer, you had to press buttons and you had to change the usability, that you can use it with VR. And to go to classes, we have two HoloLens, so we wanted to bring it to the HoloLens. We are looking now for, as Constance said, for students to make this switch. And I don't know if it helps if I say it here, but I hope that Google and Apple brings out some AR, VR classes pretty soon, because then I think it's much wider to the market and will be much more usable for many more people. Because even the construction companies and the engineering office we're working with, they say the HoloLens is a little bit too expensive for the use case. We don't use it too much. So they need much more use cases where they have really a surplus value for the company. And I think when you have a AR, VR class, which can use much more easily, where there are much easier apps to use, then I think this will help to broadcast and to really make more of this class and more use of this AR classes, because we saw that it's really, in some of our other research projects, that the AR classes can bring a real extra effort or a real extra bonus compared to tablets which you hold on your hands. You don't have your hands free, for example.
One is a short question. If I understood it right, you are only supporting Android?
Yeah.
So why not iOS? Because I see at least 50% of my students have iOS.
Even more. So that was a key point. We used Unity, which has the ability to be exported to for Apple devices as well. But we are currently replacing this closed source plugin, which I was showing in the presentation, which is not supported by iOS. So that was a limitation basically of my time in the master thesis. But we are really working on that now to get rid of that. And also during this process, we can think about open sourcing the whole solution, because this one closed source dependency was really the only one which was holding us back to bring this even to a more open level for everyone.
My second question is, we are here in a students' award. You listed quite a team, and your partner from this age, doesn't fit to student. So how much of the work which has been presented here was really your work, and how much was by other partners around here?
So the programming was completely done by me. So the solo development of all this, the development of the models and 3D models was of course done by students and teaching teachers at the university. But that was always interplay between me integrating new features and them recommending me basically new aspects or showing me new things inside IFC, since I'm coming from the computer science department and have no prior experience with civil engineering, and that's was an interplay basically. And I think that I'm not really sure when we submitted our project, but this state right now really only shows the stuff which I did during my master's thesis. And I have worked on this inside of the research unit for the last 8 months or so since the submissions, and really improved on that as no longer a student, you could say, or away from the master's thesis. Yeah.
I would add just for a moment that the whole platform and the 3 applications, they are continuous work. The content is something which we added with students, and they did the evaluation then. So that we evaluated the stuff and we needed the students for giving feedback and so on.
Excellent. Are there any final questions from the jury? No. Thank you very much to all of our speakers. We'll see you this evening for the awards ceremony. If everyone else could now leave the room, we'll have the jury deliberations.
Thank you. Bye-bye.
Thank you very much.
Bye.
Okay.